Hey everyone, welcome back to our channel. Have you ever looked at an engineering drawing and wondered why the views are arranged in such a specific way? Why the top view is sometimes below the front view and others sometimes above it? Welcome to the world of orthographic projection. In this video, we are diving in two most important projection methods used around the world, that is first angle projection, commonly used in Europe and Asia, and third angle projection method that is used in US and Canada. You will learn the difference between them, why the layout of the views changes, and which one to use depending upon your industry or region. Whether you are a student, designer, or curious to know how the technical drawing work, this video will clear up all the confusion once. But before we get into first and third angle projections, let's understand what is orthographic projection. So basically, the orthographic projection is a method used to represent the 3D object in 2D view. Typically, the front view, top view, and side views, so that all the dimension and shape are accurately captured for manufacturing. Now let's understand two methods of orthographic projection in detail: the first angle and the third angle. In first angle projection, the object is imagined to be placed in first quadrant, that is, in front of the vertical plane and above the horizontal plane. The space around the object is divided into four quadrants using imaginary planes: vertical plane used for front view and horizontal plane used for top view. In first angle projection, the object is placed in first quadrant. The views are projected into the plane behind the object, like the front view is projected on the vertical plane, as shown on the screen. In a similar way, the top view is projected on the horizontal plane, as shown on the screen. Now, if we talk about the third angle projection, in third angle projection, the object is imagined to be placed in third quadrant. This means the object is behind the vertical plane and below the horizontal plane. In simple terms, the projection planes are between the observer and object. You are looking through the projection plane at object. The plane acts as the transparent glass screen and you draw the view as you see it on screen. Now let's break it down. The front view. You look at the object from the front. Since the vertical plane is in front of the object, the front view is projected directly on the vertical plane. And if you look at the object from the above, the horizontal plane lies above the object, so the top view is projected upward to the horizontal plane. So the basic difference between them is, when we are talking about the first angle projection, the object is between the observer and the plane. And in case of third angle projection, the object is behind the plane, means we are watching the object through the transparent plane. Now imagine there is an object and it is in front of vertical plane. Now if the observer look at the front view, then the front view is projected on the vertical plane as shown. In a similar way, if the observer look at all sides one by one and each time the object is in between the observer and plane, then each time the view is projected on the plane like this. And now, if we unfold the planes, then we get how the views are displayed in first angle projection. Moving on, in a similar way, if we talk about third angle projection, again, let's say there is a plane between observer and the object. Now, if the observer look at the front view, then again the front view is projected on the vertical plane as shown. And if the observer look at all sides one by one, each time the object is behind the plane, then each time the view is projected on the plane like this. And if we unfold the planes carrying the projected view, then we have our projections in third angle. So we got to know that the basic difference is in observer's position and nothing else. Basically, both the methods are correct with no flaws. They are given preference according to the regions and industries. Like in Europe, India, and Asia, they use first angle, that is ISO standard, and in US, Canada, they go for the third angle, that is ASME standard. Understanding these systems is crucial for anyone working with the engineering drawings, CAD software, or manufacturing design. But now you got the clear idea how each method works. Now the question arises, why second and fourth angle projections are not used. In theory, there are four quadrants where the orthographic projection can be done, based on the relative position of object, observer, and projection plane. So what's wrong with second and fourth quadrant? The main reasons are view overlapping and confusion. In second and fourth angle projection, the object is behind the projection plane. This leads to the view overlapping or appearing on the same side, making it hard to read. Then we have non-intuitive layout. The way views would be arranged in second and fourth angle projection doesn't follow the clear consistent pattern. For example, in second angle, the top view ends up below the front view, same as first angle. But the right view also end up on the left, causing confusion. The industry standards like ISO, ASME only support first angle and third angle. Not using second and fourth keep the drawing uniform and understandable worldwide. And this was all about the orthographic projection and the difference between first angle and third angle projection. Thanks for watching. If you found this video helpful, be sure to like, subscribe, and click the bell icon so you don't miss any future updates. And if you got any questions or suggestions for future topics, drop them in comment.